will be made available to you. Yeah, so be aware. I don't know when Professor Singh is going to distribute it, but at least you can. All the material will be made available for you to be used further on. I'm sure you are aware of these 17 goals for a sustainable development. Yeah, they have been developed by the United Nations, where all the global countries work together, and they have identified 17 different areas that are relevant for sustainable development. Yeah, because sustainability is a very broad area, yeah, covering many different aspects, and at least this is the basic and the most principal goals and framework conditions for our future sustainable, for future development, and of course it should be sustainable. And when we come really to the area of sustainability, of course we have to make sure that all our products and services they're really sustainable. And sustainable can only be judged if you look on the whole value chain, if you really look on the whole life cycle of all the different products. It's very important. You start with the production, the use phase, and the end of life phase. It's like a life of a human being. You are born, you live, and finally you die. And that is at least also valid for all technical systems and services. And most of these sustainability goals you've seen before are somehow part of the sustainability, which normally has three main pillars for sustainability. Of course, one is dealing with the environment. This is one key thing. The second thing is, I say sometimes it's about money, it's about the economy. Yeah? So even also the economy, the economic development is somehow relevant, yeah, to be sustainable, to do that. And the third thing is the society. Yeah? It's really how people live, how they interact, which the system you have. And so at least the society is also part of this overall sustainability. Sometimes they have a fourth pillar in this sustainability. It's called the governmental pillar. Um, it's more a question. I would say this is, for me, it's part of this society pillar, how to organize societies, which regulations you are established, and how you at least live together. And at least on one hand, we have nature, we have the resources and the raw materials you find in nature. So all the activities we are considering with life cycle assessment, they always start in nature. Yeah, that's very important. We always start in nature because this is the principal thing where we get raw materials from, where we get energy from. And on the other hand, through the different production processes, finally you can provide product and services. And the overall system, of course, should be sustainable. In the following, or in my lectures, my focus is really on the environmental part of this sustainability. Yeah? So it's really about the environmental assessment of the different technology with a special focus to biofuels. Of course, they have to fulfill economic criteria and social criteria, but my key focus is really on the environment. And when you do a sustainability assessment, at least the overall framework, if you are considering economic or social effects, at least the overall system is always the life cycle analysis, the production, the use, and the end of life. And if you do so, at least you can identify specific indicators that makes it possible to somehow measure sustainability. It's about greenhouse gases, it's about primary energy, it's about land occupation, so how much land do you need. So at least you have specific indicators for specific areas. And there is not an overall one single number that measures sustainability. That is never not possible. If you have so many different aspects in sustainability, you cannot upgrade them to only one single number. So at least you always have to deal with many different indicators, and some of them are more robust than others. Yeah? And this is also part of my lecture to highlight those where we say the scientific basis is quite well. You can really do a good quantification, and it's a useful indicator. And on the other hand, I will also mention some indicators that are not easy to quantify. Yeah? That's so it really, and therefore it's also important. Sustainability cannot measure it in one indicator. You have many different indicators. So you also need, beside this technical information on indicators, in parallel, you always have to talk to people to discuss about setting priorities. What is your key interest? What is your key focus? What is your key need? Yeah? And this is more a process of interacting with people, and in combination with scientific indicators that give you a basic information about the different systems, you have the possibility to make the right decision towards more sustainability. Um, what are two um, I come from Austria, from Europe, and we in Europe are very much focusing currently on two key aspects of sustainability, which include at least many, many different sub aspects. But one is really the global warming, yeah, that we have an increase of the global temperature. I also heard here that here at university the winter is getting warmer and warmer. Yeah, and it's the same in Austria. We have less snow in winter because it's really an increasing of the temperature observed, which is due to global warming emissions. And the key element here is really to limit the temperature increase by the end of this century, maybe by 1.5, 2 degrees, 3 degrees. Everything more even makes more trouble in adopting the planet to increasing temperature. And this is a key driver also for life cycle assessment, for sustainable energy, to really reduce greenhouse gases. Finally, they should be reduced totally. So this is one key challenge we are facing. And the other one is about circularity. And circularity means we're extracting so much raw material in different kinds of raw materials, not only raw oil, it's minerals, so water, so many things. And of course, the more we use these materials, the longer the lifetime of these materials. That is in favor for sustainability. And of course, we should create less waste as possible. So the more we really can close material cycle in a so-called circular economy, of course, this is also a key pillar. Also in Europe, we have this big Green Deal focusing mainly on these two aspects, beside others, but these are the key aspect: circularity and limiting global warming. And this is a typical picture you find, for example, in documents from the European Commission. But if you look on this concept of circularity and you have a technical background, so to say, this is not a real symbol for circularity, because if in this circle still materials go in and materials are coming out, even this graph is not circular. At least a 100% circular economy is really 100% closed cycle of all the materials. And that is finally what we see in nature. In nature, you find no waste. Yeah, we had the opportunity yesterday to visit a farm nearby, a small farm, and on that farm they have no waste because they harvest and leave back the leaves and bring back the organic residues. Yeah, so this in nature we see how a closed cycle work, and this is the main idea we also want to transfer to our technical system, to our technical world. Yeah, that all of the materials we have around, that we are really able to use them as long as much as possible, and finally to reuse it for other purposes or for the same purpose. So this is the principle of, of circularity. And on the very beginning, of course, you have to consider what are the key drivers for creating more and more greenhouse gas emissions that are mainly influencing sustainability. And you can apply this formula to different, here it's applied to greenhouse gases, but you can also apply it to water consumption or raw oil consumption. But at least there are four main factors that are influencing the overall greenhouse gas emissions. And I will explain them to you, because the total product of these four factors is the tons of CO2 equivalent. The equivalent is the sum of all greenhouse gases we have. Yeah, it's not only the CO2 from fossil energy, it's also methane, NGO, and many, many other substances contributing to global warming, But of course, the CO2 is the most relevant one so far, but at least they are summarized as CO2 equivalent. And these four factors, the first factor is an emission factor. Yeah? It tells you how much greenhouse gas emission per unit of energy do you create. Yeah? For example, if you burn 1 liter of gasoline, you create 3 liters of CO2, but you also get a 10 kilowatt hour of energy. Yeah? So it's how much greenhouse gases per unit of energy. This is the emission factor. And of course, the more we have renewable energy, the lower these emissions become. We will see they will not be zero, but they might become close to zero. This is the important thing, yeah? But at least this is the emission factor depending on the kind of energy you use that gives you the greenhouse gas emissions per energy. The second thing is how much energy do you need for a specific service? The service can be the preparation of a dinner or a lunch. The service can also be to lighten up or cool or heat this room here. Yeah? But how much energy do you need? Yeah? And depending on the room, depending on the circumstances, you have the same room, but you need more or less energy for a good cool or temperate, good temperature here. So it's a factor describing the energy efficiency. Yeah? And of course, the less energy you need for the same service, the better it is. And if you have a smaller car, you need less energy per kilometer compared to a bigger car. This is relatively easy to understand. But energy efficiency is really, really very important to really be as energy efficient as possible. The third factor is also relevant. How much services do you need, you personally need? Yeah. How I start again with an example from eating. Yeah? How much do you eat? Where do you live? How big is your car? What is your personal need? So really, how many services you need per person, that is also influencing the overall effects. And the very last one is you have to multiply it with the number of persons. And multiply numbers of persons, service per person, energy per service, and greenhouse gas emissions per energy, at least you end up with the overall tons of CO2 per year, per country, per whatever, per capita. Yeah? And this describes the key drivers making greenhouse gas emissions. And this is also describing the main area. That's why I like this formula personally very much, because it describes exactly the type of research my colleagues and me we are doing at the institutes, because we have technical people at our institute. They are dealing with the energy efficiency and they are dealing with the emissions from energy supply. Yeah? Because this is really describing the energy system, at least describing a future energy system. And this is a technical issue. Yeah, so you need technical people working on more efficient systems, or more systems using renewable energy. The other two ones is about, at least it's about the lifestyle. Yeah, so what is the kind of life you're living? Of course, you see here in India, you have a different lifestyle than we have in Austria or the people in the US have. So everybody has a very specific kind of lifestyle. Yeah, and at least you might say, last thing we want to do is we all want to have a good life and a happy life, and the surrounding can be at least quite different. Yeah, so it's also about having a good life, and you might have a good life with more or less energy and more or less greenhouse gas emissions. Yeah, so there is an interaction between lifestyle and the energy system, and that's why our research group is called Future Energy Systems and Lifestyle. Because for the lifestyle, this is not an issue for a technical guy like me, not for the engineer. It's for people with a social background, yeah, and describing lifestyle of people. And finally, we think if we really want to reduce greenhouse gases, we have to work at least on three of these factors, maybe also on fourth, but at least on three of these factors we have to work, because they have to go down. And one key issue is the number of persons. Yeah, and it's not only about a big country like India is. I can tell you, I come from the city of Graz. We have 250,000 inhabitants. But people like to live in Graz. So year by year, more and more people are coming to Graz and living in Graz. So on the end of the year, if we make a balance over the emissions in Graz, we should not wonder that we have more emissions than in last year, even if they have the same lifestyle, so to say, and the energy system is the same. But if we have 5,000 inhabitants more on the end of the year, we could not wonder that we have more emissions if you only look on the city of Graz. Um, of course, it's about service per person, energy service, and about greenhouse gas emissions per energy. The nice thing on this formula is if one of these four factors is really zero, then the overall product is zero, then we have solved the problem. Yeah. So do you have an idea which of these factors might become zero, yeah, and might really have a strong effect to decarbonization? Pardon? Yes, they can all. Service per person can be reduced, yeah, yeah, but not to zero because you need food, you need a house, you need a place to work here, yeah, yeah, yeah. Yeah, that exactly. It's the emission factor. So if we really have an energy system that has no greenhouse gases, really zero emission, but you still get energy out of it, then it might solve the problem. But as soon as you start doing a life cycle assessment on any energy system, you see it's never zero. It can be reduced. It can be reduced significantly, but it will never be zero due to natural law, I would say. However, yeah, so that means we have to work on all three factors quite a lot, yeah, because when you multiply them, of course, to that, then you see, and the total product must become smaller. And I give you an example from Austria how difficult it is to really reduce um, the emissions. Um, I'm not showing you so many formulas in my lecture. I think on the beginning it's the most complex formulas on the beginning, but at least it's at least a little bit the comparison. On one hand, you have a technology development, on the other hand, you have the energy demand. Yeah? And the energy megajoule per year you need, if you're in the transport sector, it depends on how much megajoules do you need to drive a car for 1 kilometer. Yeah, that's technology. That's depending on the car. And secondly, you have to multiply it. How many kilometers per year are you driving? So these are two different things. Yeah? The first one is the technical one, energy per kilometer. And the other one is, let's call it lifestyle. How many kilometers per year do you drive that car? Yeah, and when you multiply that, then you get the energy demand per year. Yeah? And if you look here on the graphs here, this is the Austrian transportation sector, the energy demand in Austria in the last 20 years, so to say, and we start in the year 2005 just with an index of 100. Yeah, and you see here the green line tells you that the vehicle energy demand of the average Austrian vehicle roughly decreased by a 10% in the last 20 years. This is not very much, I would say 10% in 20 years. But anyway, we see that the new cars need less energy. Because I studied mechanical engineer, and 99% of my colleagues, they went to the automotive industry. Because that's a typical activity for mechanical engineer, at least in the Central Europe. And when I meet them, they always tell me, we are making so much more efficient vehicles. And then I can tell them it's true. The vehicles you build today, they're really more energy efficient than vehicles we had in the past. But the most important is the red line. How much vehicle kilometers per year did these cars drive? Yeah? And we see in Austria we have an increasing car fleet. So we have more cars this year than we had in the past, is one effect. And second effect is um, people have a car and drive more kilometers year by year due to many, many things, so to say. Yeah? So if we have more kilometers driving per year, yeah, this is the lifestyle effect. And we're interested in product. How much energy per year do we really have? So we have to multiply the red and the green light, yeah. And you see that the energy demand in the past still increased significantly, even we have an improvement in energy efficiency. Yeah, and this is at least the two things you have to consider. There's always a technical component, which is developed by the engineers, and the other thing is really a lifestyle, how people use a certain technology, and then you end up with a real effect in energy consumption or in greenhouse gas emissions. And so the good message is we see everywhere that energy efficiency is increasing due to technology development and its implementation. Because if you have only good technology in laboratory, it doesn't help. You really have to bring it in the economy. And at least the other thing is, the second positive message is this curve also gives you a possibility to reduce greenhouse gases. Yeah? Because when you say that the driving, the kilometers per year has such a strong effect, yeah. So if you put an effort on reducing the amount of driven kilometers, you can also reduce greenhouse gases, yeah. And this is of course a big question: is this possible or not? But this formula gives you the possibility. And sometimes, if I make a joke, I tell the people in the Corona time, we also had forced to, to, to stop certain activities. Yeah, and we have very strong greenhouse gas reduction targets. We in Europe, we want to reduce greenhouse gases by 2030, which is in 5 years, by 55%, referring to 2005, which is really a strong decrease. In Austria, we want to have no greenhouse gases in 2040, which is even very ambitious. But if you think on these goals, if we stop driving our vehicles in July, yeah, that means we only drive 50% of the annual mileages. Yeah, if we stop driving in July, we can reduce greenhouse gas emissions by 50%. This is on one hand a joke, on the other hand, just also an example on different measures outside of technology which are also relevant to do that. Yeah. You have a question? No. Okay, so in our research, of course, we have a strong focus on research because we think people are in the focus of everything. Yeah, it's all about us, and it's about our daily need. Yeah, so what do we need daily? You see that on the graph here. Of course, the housing, we need to live somewhere. Yeah, uh, we need to eat something. We need the food. Yeah, we need. It's called consumption. We like to go shopping. We just talked before the good possibilities of going shopping also here in India. Yeah? It's about information. Yeah. So if you come here today, it's about information. Yeah. I bring some information and you can get some information. So we have a need on information to come here. You need mobility. So this is a principal need. It's also a little bit about recreation. You know, I come from Austria. We like skiing. So you see some skiing here, but people have different activities in their free time. But these are more or less covering all the different areas, all the different needs we have. Yeah, and at least question. Yeah, and yesterday we visited a small village. I point out over there. Yeah, and in that village. They had everything, most of the things they really need, they have in the village. They can buy everything, they have most of the things. So, of course, they have to go. You always have to go somewhere. If you don't have the thing you need here, you don't have it. If you want some water and I don't have water in the room, I have to go somewhere. Yeah. Of course, mobility starts when you need something you don't have at the place you are. But it's a question: how long do I have to go for a glass of water? Yeah, where's the next possibility to get water? Yeah, and of course, if you have small areas where you have most of the things available, of course you don't have to move so far. Yeah? And the second question is, okay, how can I go there? Yeah? If I need a glass of water, I normally can walk there, hopefully. Yeah? But for information, of course, to come here, maybe you have a longer distance. Maybe it's too long to walk. I had to fly here because for walking it was too far. So it's really a question: which possibilities do I have to fulfill my need for mobility? And finally, how do I decide? It's also a question of possibilities. It's a question of money. When it is at least, but this is the way where mobility really starts. That's for us why it's so important to start really with the lifestyle, to ask the right questions, and then we come to the technical system providing you these different services. And in our research, we have many research questions on at least sustainable lifestyle, on low carbon lifestyle. And this colorful picture just gives you an impression lifestyles can be so different. Uh, the way you live, what you like to eat, where you go for holiday, what are your interests. But at least we have 4 key questions in our research we ask all the time. The first question is, who are we talking about? Is it young? Is it old? Is it rich? Is it not so rich? What about this education? Which kind of education people have? So that starts where people have different lifestyle because they have a different background, even in which country you live. So this is the first question: who are we talking about? Um, the next question is, how much do these people need? Yeah, what is the daily need for mobility, for food, and for their activities? And what is their way? The third question is, what do they consume? Here, for example, we've seen you have much vegetarian food or only vegetarian food. Yeah. So this is a clear, you have vegetarian food. This answers the question, what? Yeah. We in Austria tend to eat much more meat. Yeah. So it's really also a question, you're hungry, you want to eat something. Yeah. The question is how much you eat is one question, but also what do you eat? Yeah. And we all know that the vegetarians, in overall, they have a much better greenhouse gas balance than the so-called meat eaters, yeah, because producing meat makes much more emissions, yeah, and this is at least a question of lifestyle, yeah, and and the last question is the most complicated one. Why are people so different? You cannot answer that simply, yeah. But it's part of our research to really understand different lifestyles and to really address people with specific measures that have the possibility to reduce finally greenhouse gases. Yeah, this is at least what we address, and these are the 4 key questions on sustainable lifestyle. And I would say only 2 of them, how much and what are the technical questions. Yeah? How much energy do you need and where is this energy coming from? Whereas the other 2 questions are more for the social people with a social background and describing the society. Coming back to Austria, to the greenhouse gas emission we have in Austria. Yeah? These are the greenhouse gas emissions per year, per capita we have in Austria. Yeah? And you see on the y-axis, I have some German slides because I also want to give you a little bit of a German lecture within, but I will explain. So on the y-axis, you see the greenhouse gases in tons, greenhouse gas per capita and year. And on the y-axis, you see the 9 provinces we have in Austria. So we have 9 provinces, and the final one is the Austrian total sum. And you see in the different provinces, the first one is Vienna. I think most of you know Vienna. We come from Styria, Steiermark, yeah? And there's Upper and Lower Austria, and the overall Austrian is roughly 9 tons of greenhouse gases per capita. So the average lifestyle in Austria makes per year roughly 9 tons of CO2. But secondly, you see that the people in Vienna, they only have half the emissions. They only have 4 tons. Yeah? We come from Styria, we have even more, we have 9. The ones in Upper Austria, they have 15 tons per capita. So it's 5 times more than in Vienna people in another province have. Yeah? And the big question, could that be? Do people live in Vienna more sustainable or climate friendly than we do in Styria or they do in Upper Austria? Yeah? Because then it would be one possibility. If we all go to Vienna, we would all have low emissions. Yeah? So you see somehow this is tricky. Something must be wrong on this view. Yeah? And this is at least the official greenhouse gas reporting. You find India is doing these reports every country globally has to fulfill these criteria, and they only count the emissions that really occur in a specific area. Yeah, so the emissions you see here, the overall sum is really the physical emissions in Austria or the physical emissions in Styria, yeah, which has at least nothing to do with the lifestyle there. Yeah, and if you look on the colors here, you see the blue one is the industry. Yeah, and you see here Steiermark, Niederösterreich, and Oberösterreich, they have much industry because there we have the heavy industry, mainly the steel industry. And you know, the steel industry makes quite a lot of emissions, but the steel industry has nothing to do with the lifestyle of the people living there. Yeah? Because in Styria, we make railway tracks, yeah? Very efficiently, very good, and everybody has to build more railways. Yeah? But 99% of them are exported. Yeah, because it's really for export. Emissions occur mainly in Austria, but the product is exported. So this has nothing to do with my lifestyle. Yeah. On the other hand, we're importing in Austria many vehicles from abroad because we have no vehicle industry so far. We are importing all the electronics, all the handys, all the computers. They are made here in Asia, yeah, and batteries here, make the emissions here, but we use them. And at least this is a total different way compared to these national greenhouse gas emissions. So my message from this picture is that these national greenhouse gas emissions per capita become totally obsolete in the global economy. Yeah? Because independent where you make the emissions, it's a question where people use these products and services. Yeah? And this, at least, is one step towards thinking about lifestyle and life cycle assessment. So I give you an example. When you go shopping in Austria in a supermarket, yeah, you can spend 10 euros for a product basket like this, but you don't get you get all these products, but not a full product. You only get a little piece of chocolate, a little bit of the bread or the water. The idea is this is a basket from the supermarket which helps us to count the inflation rate. Yeah? So you go shopping each month the same things, and you see if you pay more or less than in the month before or the year before. But it's normalized to a 10 euro basket. Yeah? And we took, in our comparison, we ask ourselves, how much CO2 do you emit by buying these products? Yeah? And we found out when you buy for 10 euro in the supermarket, these products, until they end in the supermarket, in total have 4 kilograms of greenhouse gases emitted. You don't see the greenhouse gas because if you buy a bottle of milk or some potatoes, you don't see the CO2, but in the supply chain until you can buy it in the supermarket, yeah, there's a whole chain behind that made already emissions. So with this 10 euro, you have a 4 kilogram of CO2. And then you might say, Pooh, is this much or less? You have no clue. And this is also later on you see in life cycle assessment, if you have only one number, it's difficult to count, is it much or less? Yeah? So you have to find something to compare it to. You can compare it to driving a vehicle, an average vehicle. If you drive this vehicle for 20 kilometers, you emit exactly you emit 4 kilograms of CO2. Yeah? So you can say, if I drive 10 kilometers to the supermarket, spend 10 euros to buy something, and go back 10 kilometers, you spend with the driving the same amount of greenhouse gases with the shopping you did. Yeah? And this is at least, this is life cycle assessment. Yeah? To give a comparison. And the question of this supermarket chain was, we had no clue in the very beginning how it was. And normally, if I go shopping, even in for the whole family, I spend more than the 10 euros. Yeah, yeah. So at least it might be if I shop for 100 euro, yeah, I have much more emissions created with the type of food I'm buying. Yeah, the more meat and the more milk products I buy, the more emissions I have. The more vegetables and the more fruits I buy, the lower these emissions are. Yeah? So at least this is just a way of applying a life cycle thinking also in our daily life. And then there's a new answer is what is the real emissions of the average Austrian if you apply a life cycle assessment to all the activities the Austrians do. Yeah, they have the need for mobility, they have the need for food, for infrastructure. Yeah, for example, the universities are part of the infrastructure. The living is the housing. It's information and communication, a little bit of waste, and a big amount is goods. Yeah, my daughters would say this is going shopping. Yeah, yeah. So all the things you buy, the clothing and all the other things are in that. So you see, this is the real greenhouse gas emission of the Austrians. And you see, if you sum that up, it's between 13 and 15 tons of greenhouse gas per capita and per year. We've seen before it was only 8, which was a wrong inventory, but in reality, it's nearly the double amount, where only half of it physically is emitted in Austria. The other half is emitted somewhere in the world. Yeah? Even here in India, things you produce here and export to Austria, yeah, also the Austrians are somehow having part of the emissions here or in other countries. Yeah? And this is at least the real overall greenhouse gas emission as a starting point to develop measures to reduce greenhouse gas emissions. And you see here that the overall, the biggest one is really the goods. Yeah? But the goods also include, of course, all the truck transportation. Yeah? Because all the trucks driving around, they only bring the products we need for daily life. Yeah? So they are counted here in the area that needs to supply the services. It's a mobility. It's 1/4 is mobility. Yeah, that's a typical European average, I would say. Food is at 10%. Yeah, and we separated this down to other lifestyles, and then you see you might have if you're vegetarian, you only have 30% of these 11, so it's a 3% would be here. So really, depending on this, is the average food consumption. The main message here is really this consumption-based greenhouse gases really starts with the daily needs of the Austrians supplying you the materials. Okay, coming back, what are the characteristics of a future energy system? So this was about lifestyle, and this is about the energy system, and it has one pillar is, of course, use renewable energy. Renewable energy is wind energy, photovoltaic, hydropower, and biomass. Yeah, these are the main energy carriers you can get from nature, and with a high efficient system, you can provide useful energy and the energy services you need. On the other hand, you also need other factors for this energy. Yeah? So if you once have the energy, you also need a system to use it. For example, if you have electricity, you can put the electricity in your washing machine. So depending on the type of washing machine, how much electricity do you need for a certain energy service? So you also need these other factors. Yeah? And also, when you live in a house, depending on the type of house, you might spend more or less energy for heating and cooling. And so this is at least another factor. And the more efficient you're here on the right-hand side, the less energy you need on the left-hand side. Yeah? And people tend to say we just need to build more wind turbines, more photovoltaics, and everything will be solved. But we also have to think about energy efficiency, about the other elements you need to supply an energy service. And I would say here we have much more possibilities to become more efficient, because the more efficient we are on the right hand side, the less on renewable energy we need on the other side. And why can't we say, if it's renewable, it comes day by day, year by year? Why do we have to be careful about using it? Because we don't have so much. We cannot build so many wind turbines. We can build wind turbines where we have the wind blowing. You can build a hydropower plant where you have a river, but we don't have rivers everywhere. We have sunlight, but not also sunlight not everywhere. Yeah, so we are still limited somehow to the amount of total energy, renewable energy we can really harvest, so to say. Yeah, so we are limited on the left hand side. So we also have to work on the right hand side, and this at least describes the energy system on one hand with a lifestyle, and on the other hand providing the energy service with a high efficiency based on renewable energy. And one important energy carrier, of course, is biomass. And the nice thing on biomass is that um, on biomass is that we have so many different types of biomass. Yeah, when you start breakfast in the morning, it's biomass. For lunch, you have biomass. All the food, of course, is biomass. Yeah, but also the straw or the wood you cannot eat is an energy carrier. Also, the dung and the manure can be used as energy carrier. Yeah, we can even use the corn or the rapes or the mustard you have here around. Yeah, you can use the oil for eating, but you can also use it for biodiesel or other purposes. So some of this can be used as food, as feed, and for technical systems, but at least you have so many different types of biomass. And when you apply a life cycle assessment to biomass, you have to be very clear which type of biomass you're really addressing. What is the type of biomass you need for your system? And we know from our we have so many different systems using biomass, but what we know about biomass, there is competition about biomass all the time. Yeah? There's a competition between food and feed. Yeah, the more animals you have, the less feed, or vice versa. Yeah, there's a competition on bioenergy. Even then, if you make heat or heat and electricity or transportation fuel, this is a kind of, of um, of competition, and of course for biomaterials, paper, construction material, chemicals, cotton, rubber, fertilizers. So at least what we see is that we always have a competition on biomass, and so how are we going to handle this competition on biomass? And we had in Europe, also in the US, but more in Europe, a discussion when we talked about biofuel, about maize or corn. I don't know if you call it corn or maize. It's the same. Yeah, we call it more corn, maize, but sometimes they call it corn. But if you have, for example, some corn left, yeah, all the corn you need for food. For example, if you go to the cinema and have popcorn, or if you have already fed all your animals and chicken with corn, but you still have corn left. Yeah? The question is, should you do with that corn? Yeah? On one hand, you can say, I make bioplastic bag, yeah? Because you can make a plastic bag out of this corn, yeah? Which is a chemical process where you use the starch, yeah? To make a plastic, and its plastic bag is made from maize. It's a renewable resource and decomposes naturally. Yeah? You can throw it out of the window, and a few weeks later it might disappear. Yeah? That is one advantage you might have. The others say, I can use the same corn and make an alcohol, make the bioethanol to drive my car. Because there it's made from maize, it's a renewable resource, and it reduces greenhouse gas emissions because it substitutes gasoline. So the big question is for us, what is more sustainable? What is better? Should you make the plastic bag with the same piece of biomass, or should you make bioethanol? Yeah? And it's a long discussion. Yeah? Do you have an idea? What would you prefer? Which one? The bioethanol? Yeah. Why? Yeah, it might be, but not in all the cases. Yeah, yeah. But here you substitute a conventional oil-based plastic, and here you substitute oil-based gasoline. Yeah? But you have a strong background in bioethanol, so you think this is the way forward. Yeah. It's a tricky answer. I found one answer when I was in Canada. When I was in Canada, I found a poster saying corn-fed cars are better for the environment. I don't know if you say in India also to feed cars with corn, but in Canada and North America, they are a little bit less emotional. They just feed the cars with corn. And they say this is good for the environment. Yeah, yeah, like you said, because you have an attitude that feeling that the ethanol is quite good. But from a scientific point of view, is really the question: is this true? Yeah? Can you really find evidence that really the corn being used for ethanol driving a car is better than making plastic? I can tell you from a scientific point of view, it's really tricky. It's really tricky. I'll show you the answer a little bit later. I'll show you another example. What we are discussing is when we see a tree. Yeah, this is a nice tree. Huh? You can leave it there and say it's just nice, just leave it. But you can say, I make pulp and paper. This is not a typical pulp and paper tree, I'm aware, but at least you can make pulp and paper out of wood. You all know. Yeah, yeah. Or you can say, I just burn it for power and heat or preparing food. Is one possibility. Yeah? And the question again is it better to make pulp and paper out of this tree? Or is it better to burn? What do you think? Pulp and paper? Yeah, but we need, yeah, it's again a tricky question. Yeah? At least we need both. What is important, you have to think a little bit more. Yeah? Because if you look on that tree, at least a more specific question is, which part of the tree do you mean? Because with the branches and the leaves, technically you cannot make pulp and paper. It does not work, but you can burn it. Huh? The branches you can burn and make heat and electricity, if you like. So say, maybe some part of this tree is good for pulp and paper, and the remaining part is good for energy. That sounds good, because you have one source and can make different things. Yeah, and you can also ask the question: are we talking about today or in future? In future, I put here an electronic device here because we are getting more and more used to electronic equipment. So maybe in future we need bioplastic and renewable electricity because need less pulp and paper. I'm an old guy. I still need some paper here to guide me through my own lecture. Yeah? But in future, maybe we need more bioplastic. Yeah? And more renewable electricity, and maybe less heat also because we have better buildings or other ways of supplying heat and electricity. So it's always important to ask more specific questions. And this is very relevant if you look on life cycle assessment, because you first have to be clear what is the question you're interested in. And you only get then an answer for this question. If you ask a different question, you get a different answer. Yeah? And sometimes people mix that up a little bit, but as scientists or as future scientists, you have to be very exact. What is the question? What is the framework? And this is the answer. Yeah? And so therefore it's very important to think about what is the key question I'm interested, and then giving an answer. It's also a question if you address here biodiversity or greenhouse gas emissions or other pollutants. Yeah? So what is your interest? So this really has to be specified. But coming back to what is better, the plastic bag or the bioethanol? And I can tell you, maybe it's um, uh, a bad answer for you, telling you that science cannot answer this question, what is better. Yeah? There is no scientific evidence that the material use of the biomass, which is the plastic bag, has a greater sustainability benefits than the energetic use, than just burn it and drive a car or heat your house, or vice versa. There is no scientific evidence to do so. So so we can finish the lecture today, because if I have no scientific answer on that, why spend a whole year, a whole week here on the LCA and saying you on the very beginning there is no way. There must be a second part of it that gives you another one. But there is an evidence, if you use the biomass for energy and material, yeah, they are somehow twins, the energy and the material use, which we call somehow biorefining. I will explain later. This has the potential for large sustainability benefits. So we will see that it's always a combination. If you use biomass, independent which type of biomass, it's always a mixture of energy services and product or material services. This is the inherent properties or characteristic of biomass that you have to keep in mind. And they have together a large sustainability potential. That's also important. That does not mean it's always sustainable if you use that for energy and material. No, it has the potential. And this is what LCA can show you. Is there a potential to reduce greenhouse gases? Is there potential to increase biodiversity? Yeah? This is not happening per se. You have to, it has the potential, and if you do it the right way, you really have the best way to do it. So this is the answer. Plastic bag and bioethanol, you really have to make an overall detailed comparison. Yeah? And with the plastic bag, you always have energy products coming along. Yeah? And with the bioethanol, you produce animal feed as a side product. Yeah? So bioethanol alone cannot be produced. And this means we are talking about a biorefinery. Yeah? And a biorefinery is the same thing as an oil refinery. An oil refinery makes you energy carriers and raw materials for plastics. Yeah? And the biorefinery also gives you an energy component, different energy carriers, and it also gives you a material for bioproducts, for chemicals, for animal feed, for human feed, for fertilizer, and so on. So this is the technical processing. I will also talk in my coming lectures more detailed on biorefinery. But biorefinery really means with biomass, you always have to make a kind of biorefining, because to use the potential of biomass always need to use the different components for the best purposes. So that means we don't have only this competition of biomass, what is used for what. We think that this biorefinery approach really has the possibility to integrate the different products, because we need different products. We need energy, we need materials, we need food, we need feed, and the biorefinery really has at least the potential to provide this. In the last 10 minutes of the lectures, I will zoom in a little bit more on the energy, always a little bit on transportation fuels, and we are talking about renewable transportation fuels, and we need more and more renewable transportation fuels, and at least we have 4 different types of renewable fuels. Of course, biofuels, they can be made from biomass. And we will learn later on also, oops, I don't touch it anymore. We need biomass, we need sustainable grown biomass. In future, you will see it will maybe also be necessary to really certify if this biomass really follows sustainability criteria coming from forestry, agriculture, and also residue. So this is one source for biofuels. Secondly, it's also you can use electricity for electric cars. Electricity should come or must come from renewable sources to really have significant environmental benefits. If you burn coal to drive a car, that's not our intention. So here you really need renewable energy, at least renewable electricity. You can do the same if you make hydrogen out of the electricity and drive a hydrogen car, or vehicle, is also a renewable fuel. And last but not least, these e-fuels. I don't know if there's a discussion also going on here in India about e-fuels. On the next slide, I explain you what these e-fuels are. They are made from renewable electricity and a CO2 source to combine it to a synthetic energy carrier. So these are in principle the four options we have to drive a vehicle, which is not only a passenger car, it's also a ship or an airplane. We have these possibilities to use renewable energy in the transportation sector. Just to explain briefly what are e-fuels, they're called electrofuels because they start with water, with CO2, and renewable electricity. That's the starting point. And you use the electricity first to split the water into hydrogen and oxygen. You need energy there, you know. And with the CO2, you have to use energy to split the carbon from the oxygen. That also needs electricity. And when you have hydrogen and carbon, with a certain, you can create all carbohydrates you like to have. And this is at least what the e-fuels are doing. Then you can end up with a gasoline quality, diesel quality, methanol, naphtha, methane. You can make everything out of carbon and hydrogen because these are the basic elements, as you know. But you always start with water and with CO2. So all the energy is coming from the electricity. And you need much electricity to split the water and much electricity to split the carbon. And finally, if you use this energy, you burn it in a vehicle and you create again water and CO2 and the transportation service. And in this formula, you can say, okay, it's the water going in the circle, the CO2 going in the circle. And the only thing is we need renewable energy to drive the car. That's what remains. And the rest is in the circle. So that's why it's basically renewable. It's basically circular, so to say. But it's not so energy efficient because you have to split the CO2 and the water. But anyway, it's one possibility that the e-fuels might be an energy carrier in the transportation sector for the future. And that's the reason why on this picture you see an aeroplane, you see a big truck, and you see a ship. I don't know if you see the ship in the back here, but a big container ship might be a typical application for an e-fuel in future, like biofuels do. But this is one segment because you cannot fly an airplane with electricity. You can fly it with biofuels, but not with electricity. So finally, it's a question, what are the best areas for this renewable, the optimum application of these vehicles? They all use renewable energy. And the question is on the x-axis, how far do you want to drive, or how big is your vehicle, and how much you want to drive, and the y-axis is how big is the vehicle. And you know, for battery electric vehicles, if you have a small vehicle with a small driving range, that works with a reasonable size of battery. If the vehicle becomes bigger, it might be an area for applying renewable hydrogen with a fuel cell. Even if the vehicle is getting bigger, this is the area for biofuels. You can also drive a small vehicle on biofuel, but there are other possibilities, but you cannot fly an airplane with battery electric. So at least the biofuels have really, due to their strong energy content per liter or per kilogram, they are very suitable for big vehicles and heavy loading and longer driving range because they're very close to conventional diesel or gasoline. And the e-fuels at least have the same area to be applied. They have the same energy content. But of course, the energy you need to make the e-fuel is much bigger. And it's also a question for the e-fuel where the CO2 is coming from. And at least it must come from the air to be circular. But you know, the concentration of CO2 in the air is too high for global warming. But for technical purposes, it's very difficult to get this 420 parts per million out of it. Technically, you can do it, but you need many cubic meters of air going through your system to get 1 ton of CO2. But only then you're really in a closed circle. And the second possibility is if you take the CO2 from biomass combustion. If you take the CO2, when you burn biomass, you get the carbon out of CO2 in a higher concentration, because in the chimney you have 12 to maybe 18% CO2, which is technically much easier to get out. But still the CO2 is then uptaken again by the photosynthesis. So at least this is also a closed cycle. Sometimes e-fuels are discussed with the heavy industry, in the steel industry. Well, they burn coke, but if you take it there, you reduce the emissions from steel production, but the CO2 is still fossil based. So the e-fuel then is not a real e-fuel because it still has that fossil carbon in there. You use it twice, but this is at least very tricky in LCA to apply that, but this is at least not the type of renewable energy carrier I have in mind. In that case, the CO2 really must come from air or from biomass to fulfill the circularity criteria. Coming back, what is the current and the future energy consumption in the transportation sector? You see here from 2020 up to 2050. Today, everything is based in transportation sector to nearly 99% or 98% on fossil energy. And in future, we hope that more and more hydrogen, electricity, and biofuel will come in the transportation sector is one thing. And these are scenarios from the International Energy Agency. And they also hope that the overall energy consumption will decrease due to more efficient vehicles. An electric vehicle is much more efficient because you need less kilowatt hours to drive 1 kilometer because the electric engine is much more efficient than a combustion engine. This is one reason why the overall energy consumption is going down. This is one perspective why it's so important that you learn about renewable fuels, about biofuels, because we need them in future to make our transportation sector more renewable. And you also see on the right hand graph which are the vehicles we put this energy in. And you see the orange part is at least the passenger cars. This light duty vehicles is a name for passenger cars. So roughly half of the energy is spent globally in passenger cars, and the other half is spent in trucks, ships, and aeroplanes is very less, at least. The aviation sector is, let's say, maybe 5 to 8% is only aviation, so really much is shipping and rail, but half of it is really in the passenger vehicle sector, and that can significantly reduce because here is a very good area for applying electricity. So the other area for the bigger vehicles is dedicated for the biofuels. So coming to a summary from what I tried to bring you in this first lecture. What about systems perspective for people mobility in the future? It's energy efficiency. Yeah, so we really need energy efficient vehicles, and of course, it's on one hand, it's vegetarian or it's food. Yeah, if you think about walking, but it's also renewable electricity as one pillar for people mobility, and we need different technologies. Yeah, mobility starts, as I told you this morning, when you wake up in the morning and get out of bed, mobility already starts. Yeah, because in bed you don't normally find breakfast. Yeah, so we need to get up to get the food, but then we have public transportation system. We have bicycles. We have, of course, metro trams, and we have, of course, passenger vehicles. So, in my personal judgment, is that for the passenger vehicles, I would think that the electricity is the most efficient one, and that we put the biofuels and the e-fuels in the airplane and ships. Yeah, but we also need airplane and ships for transportation. So this is at least a perspective in future where we put maybe the best choice of technology with the highest energy efficiency, which is really a key for all different applications. Last but not least, to also address a little bit the mobility behavior and the lifestyle, which is totally different here in India, what we saw yesterday compared to, for example, Austria. Normally in Austria, you see one person in a big car, 2 tons, transporting one person. Here you have a motorcycle transporting 3 or 4 persons. Yeah, so this is a total different way of addressing this issue, and that's why we have developed this green box. It's the green box 2.0, and because with that box, if you put that in your car, you can increase the energy efficiency by a factor 2. There's also a box available 3.0 and 4.0. And the clue behind that is if you put that in a car and you have only one person sitting in the car does not drive. If a second person enters the car, then it starts to drive because then it's half the emission per capita for the same distance. And if you put it in the bus and in the tram, there are always more people. This is much more energy efficient. And this is at least a strong story, very relevant in Austria because all the people using their own car for them alone. And this is on the medium term a big question on changing the lifestyle and make it more sustainable. Same technology, but more people in the same vehicle. Of course, you have more service with less emissions. That's why this green box is one possibility to explain how lifestyle influences this. Finally, this is a summary of the key messages of today. We've seen the key environmental challenges are climate neutrality and circularity. They're really covering most of the environmental aspects. And the future energy system must be based on high energy efficiency. Really use less energy for much service. This is really the key issue. And secondly, the energy must come on medium to long term from renewable energy sources. And we have also seen that the type of the lifestyle is relevant, and this economic development and how many services per people is a key driver for consumption. People drive more if they have more cars and so on. So this is a key drivers. I already showed you a little bit where biofuels from sustainable biomass are part of the solution. They are not the complete solution. Yeah, because for the solution we need many different puzzle elements. Yeah, but of course bioenergy, biomass, biofuel are part of the solution beside others. But we really have to take into account that biomass, the amount of biomass available is somehow limited. There is competition about biomass, but also about land use, which is always coupled with bioenergy. We will discuss later on. Then we've seen that biorefining is at least the technical term how to use the energy properties and the material product of biomass the most efficient way. This is at least the most relevant one. And still the total amount of sustainable biomass is somehow limited due to technical, economic, social, and environmental conditions. Yeah, we will discuss that, I think, the whole week. So the available amount really depends on the circumstances. It's still limited, but it is available in different properties and can fulfill different services and needs our society has. So this is at least the final slide for this first lecture. If you have any additional questions, you can ask them now, or you can ask them during the break.
Good afternoon, sir. Sir, you just mentioned that this formation of different or manufacturing of different fuels and materials from the raw material should not be in competition but in integration. So can we say that making different products from the same material, it can compensate for the environmental impact that that process is having?
I
Uh,
did,
yes.
can you ask? I did not get the question completely.
So what I'm saying is that whatever our activity is, let's say we are making biofuels from the biomass or whatever we are making from it, it will have some impact on the environment.
Yeah.
So if we are making multiple products from the same material, can we reduce the impact on environment by doing that?
Yeah. Yes, because when you make a comparison, you make on one hand different products out of biomass. you always have to compare it to something else. So at least you have to compare it, making the products with a different way. For example, driving with gasoline or making the plastic bag out of oil. Yeah. So at least what you do, you compare if you have different products made from biomass, you have energy, you have a plastic bag, you have food or feed, yeah, and they have a certain emission or influencing biodiversity to a certain degree that you can quantify with some indicators. But secondly, you have to compare it. What would be an alternative way using raw oil for this product? Yeah? And at least in this comparison, then you can say if you have an advantage with your bioenergy system, or you have no advantage, or it's not a significant difference. Yeah? But at least you always have to compare one thing with another thing. And this comparison must be a fair comparison with the same services and for the different indicators. And for example, for this plastic bag versus the ethanol, it might be that if you do a good comparison, that you see that one case is saving more greenhouse gases, but maybe the other case is saving more particle emissions. And it's becoming complicated again. Yeah, you have an advantage here and a disadvantage there. And that we will learn during this week. There are different impact categories and how to judge them and how to handle pros and cons, where you have an advantage, where you have a disadvantage, and what you need to overcome that and to finally decide what to do.
Any more questions?
Good afternoon, sir. Earlier, you said that in Austria, if you don't drive a car for just a month of July, you will reduce the greenhouse gases by 50%. Could you explain that? That's
Yeah, at least one is the technology, and the other one is how you use the technology. Yeah, and we do improvement on the technology, but we also have to limit or regulate or learn how to use this technology the most sustainable way. Yeah? And for example, in where I come from in Graz, in the city center, everything they have due to historic reason many small roads, yeah, and you don't have space for all vehicles there. So we say there in the inner city, have to use public transport to go there, yeah, or the bicycle or walking, yeah, and for longer distances, of course, you can use the train, so it's at least really a mixture of a future mobility system is not one technology at least. Yeah, it really has to be adjusted to the need of the people, but also in line with the sustainability criteria. Yeah? And therefore we've seen that it's not only in Austria. It's if we have too many vehicles, we are running out of space to drive them. Yeah, so we really have to rethink our overall system, and this is a big challenge for our society. Yeah, and at least, but we still come back and say, okay, mobility starts when I need something I don't find nearby. So one answer is the more I find nearby, the less I have to go somewhere else. Yeah, and I could have done my lecture here, sitting in my office in Graz, do it via internet. Yeah, that could be one possibility. Yeah, and that is a choice you have to make. I still think it's good to be here to see you and feel you, but you see, there are many possibilities to think about. How can I limit my demand of mobility because I have things nearby? Yeah, for some things you really have to go to. For example, Austria has no sea, so if I want to go swimming in the sea, I have to go to Italy. Yeah, because we don't have the sea. Maybe in future I put up a Google Glass, yeah, and feel like I'm, yeah. However, it's curious, but at least it's something I think we will learn in future, because in the past the energy was available and we have developed the system, and now we see somehow the limits of the sustainability of too many cars or too whatever. So we are further developing in a more more sustainable way. Yeah, yeah. I don't know how you see the perspectives here for India. Yeah? It's also, and you don't have so many cars per capita like we have. Yeah, so it's you're at a different level, but still it's really a tricky thing to decide on that. Yeah.
Thank you, Professor Ingrid. So if you have still any questions, so you can note them down and you can ask them later, because we are running for short for the lunch. So we have to start the next session by 2 o'clock. So you can reserve your questions and you can ask later on. Okay. Thank you, Professor Ingrid. So we can now disperse for the lunch, and we will meet at 1:55. Okay.